right, folks, it's Bass Action back in action here. In this video, we are going to go over a brand new function called the greatest integer function, also known as the step function. I do want to make a note real quick that if you are working in Desmos, the integer function gets entered into Desmos as the floor. So you'll just type the word floor and then everything that you would need in the place of integer. Okay, so this first example right here is just what does a basic integer function look like? Now, its name is also a step function, so that gives us an idea what this should look like. So just let me draw this in and then I'll explain how this works. We are going to have a closed dot, a closed point on origin. Then we're going to have a horizontal, just a flat constant interval here, all the way to 1, and then it's going to be an open circle. Then the next step is going to be a closed circle, a closed dot above that. Then it's going to be a nice horizontal interval, open, and then you're going to jump up again, and you can see this is starting to mimic a set of stairs. Now we can make this go in reverse. So below our initial point, we can make an open circle here, go backwards and a step, and go below and backwards and a step, and below and backwards and a step. So you can see how this mimics a nice set of stair steps, okay? So the way this is going to work is that for every x value that we choose, the integer function is going to always make the value a whole number. So for example, if I chose an x value of 1/2, since that's not yet at a whole number, it doesn't round it, since it's not yet at a whole number, it chops it down and keeps it at a y value of 0. When I get to the next whole number, for in this case a 1, it's going to jump all the way up to the next step of 1. And then at, let's say 1.2, it stays at 1, 1.3, it stays at 1, and when it gets to the next value, it goes up. So it's always going to keep that whole number. It basically chops off any decimal portion. It does not round. Now, the nice thing about, the useful thing about a step function for us is it allows us to really work with our transformations directly. So from our last lesson, we worked with what our basic transformations were, and we're going to use transformations to graph this modified step function. So we're going to think in terms of a regular step function with all of these possible transformations. Integer step functions, just as an FYI, are very difficult to do with a t-chart. They tend to get very, very confusing for us. So what we want to do is we want to identify the x transformations and the y transformations. So when we look at this particular portion, this is going to be our x transformations. And what we want to think about is what's going to happen with each of these pieces. I have a negative right here, and I have a 1/3 right here. This negative right here is going to reflect over the y-axis. So reflect over the y-axis. And this 1/3 tells us that this whole function is moving at a 1/3 speed, which means it's going to take 3 times the amount of time. So 1/3 speed. I like to think of it in terms of a speed. So it's a 1/3 speed. So instead of being able to finish a step in 1 unit long, since it's 1/3, it's going to take 3 units to complete the step. So 3 steps or 3 units long. So each step will be 3 units long or wide. Now we've got also some y transformations. We've got a 4 here and we have a 1 here. What we want to know is that that 4 is going to make the steps 4 units apart. That means vertically apart. Okay, so 4 units apart there. And then the +1 is going to shift them all up 1 unit. So I like to start with my first step. So my first step, I know instead of going to the right, it needs to reflect over and go to the left. So the first step, it's going to go to the left and it's going to be 3 units long. So I'm thinking of a step that's going to look like this. Now, I know my step is supposed to be shifted up 1. So instead of having my first step here, my first step is going to be right above that. So it's going to start here, and it's going to be 3 units long, and then I'm going to have my open circle. Now, what I like to do is from there, I like to kind of keep going. So if my step was here, and it needs to be 4 units apart, I'm going to go 4 units up. So from there, I'll go 4 units up, and then I'm going to go 1, 2, 3, 4, and then it would have to go backwards again. So I'd go up to here, and I'd go backwards, and I can't quite finish this one. Now, I can continue the stair step idea. So from here, I can go 1, 2, 3, 4. Now remember, it has to be a function, so this one has to be the open, and then it's going to be 3 units long again. And that is the most that I could get onto that graph in this particular grid. Okay, now we are going to do a lot more with this in class, but for right now, I just want you to recognize that this is what the basic integer step function should look like. I want you to understand how this 1/3 impacts the length. I want you to understand how this negative impacts the reflection, how the 4 impacts the spacing, and how the 1 causes the first one to shift up from where it began. So those are the most important pieces of this example.